This is part D. The capacitor combination figure 8.1 is now charged by connecting the points A and B to the 9-volt battery. The charge combination is then disconnected from the battery. Next, a resistor is connected across the points AB as shown below. The capacitor is discharged through the resistor, and the table gives you some values of the charge at times. And so you were to draw a graph, plot the points and draw a smooth curve through them. So I hope you'll be able to see this. I'm going to have to scan a way out so that you can see this. This was a graph I drew here. And this is my graph here. Sorry, I might be on the wrong side of the page here. Question 8D, yes, sorry, this is it here. This is the graph that I drew here. This is a charge, goes down to this time here. And you can see there that the graph there is going down like this. Show clearly how the time constant can be obtained from your graph. Write down the value of the time constant t. So you know your initial charge was 72 microcoulombs. The time constant is obtained from taking 37% of that. 37% of that takes you down to a value of 26.6 microcoulombs. So if you're asked to show clearly, you need to draw it onto your graph. So there's a 26.6 over to your graph and down. And you can see there that it's fallen down at about 16 seconds. So the tau is coming out here at about 16 seconds. It's hitting this axis there. So you will probably have something thereabouts. It depends on how you actually draw your line through your points there. It then says to you, hence calculate the resistance of the resistor. So if I just write down here, this is part 3 of this question. You know tau is equal to CR. From our graph, we found that tau is 16 seconds. We are told the two capacitors there have got a capacitance of 2 and 6. So the total capacitance in the circuit is 8. CT is equal to 8. You just add them because they're in parallel. So it's 8 microfarads multiplied by R, which we're trying to find. And so R comes out to be 16 over 8 by 10 to the minus 6, which is going to give you 2 mega ohms. And that's what your resistance comes out to be there. The experiment is now repeated. The discharge is commenced as before, but at time t equals 10 seconds, the 6 microfarad capacitor is disconnected by cutting the wire at X. So the 6 microfarad capacitor is disconnected. So if I just show you this on here, that means that this is now gone. And all you have in your circuit is the 2 microfarad capacitor there. So after 10 seconds, the 6 microfarad is disconnected. On your graph, sketch a curve to show how this action affects the remaining part of the discharge. So you now only have 2 microfarads. That means that your new tau, that's at time t equals 10 seconds. And so the Q at that time, if we look at the graph there, if you go across from go up from 10 seconds, you have a charge of 41 seconds. So your initial charge for this circuit is 41 seconds. You know that tau is equal to C times R, and C now is only 2 microfarads, and it's multiplied by 2 mega ohms. So that gives you an answer of 4 seconds. So your time constant for your new circuit is only 4 seconds. And so if you have a wee look at the graph here, I have it sketched on already, you can see that after 4 seconds, your initial charge there at 10 seconds was 41. It has now dropped to 37% of 41, and 37% of 41 is down at about 15 there. So there's my first point, and that's taken a total of 4 seconds across here. And then after another 4 seconds, you'll have dropped then to another 37%, which I think is this point here I've plotted. It takes you down to Let me see what that is. Is it 5.6 seconds? And that's at a time of 18 seconds, and so on. So the curve is going down much, much more steeply there. And that's how you sketch the curve showing the remaining part of the discharge. Thank you.